Greetings, my name is Solians. Today I'm going to present the course SEAA3022 Integrated Design Project 1. The topic is water reticulation. Water reticulation system is a network of pumps, pipes, and water storage designed to store and distribute water to the premises. The water distribution system facilitates the movement of water from the source to the user. When shifting elevations, the water requires energy to traverse and overcome any resistance it finds. If the movement of the flow can be aided by gravity, it is more beneficial as it requires a less expensive operations. In our design project, we have applied closed-loop pipe system because it requires less pumping horsepower when compared to an open-loop system. Besides, the equipment life cycle can also be extended because the clean system fluid offered by a closed-loop design reduces maintenance. Even if a section of the pipe is closed for the maintenance, other consumers can still access the water supply, so it is necessary especially in such huge project area. Here is the list of the hydraulic requirements according to the SPAM guideline. First one is the velocity of the flow should not less than 0.3 meter per second in order to reduce the depositions of sediments. Second, the minimum pipe size should be 100 millimeters. Third, the discharge residue pressure at the higher supply level should not lower than 7.5 meters. Then, the static pressures of all pipelines should not exceed 30 meters at all flow conditions. This table shows the average daily water demands for different types of buildings. We have calculated out the average daily water demands of each node, and the total demands obtained is 913,218.60 liters per day. After that, we convert the unit to the liters per second. Then, we times with 2.5 to obtain the total peak flow rate. Then, we also calculate out the peak flow rate for each node one by one. After we obtain the total average water demands, we can start to design the water tank. The capacities of a water tank can cover up 1 day of water demands in that area. After doing the calculations, we obtain the height of the water tank should be 0.94 meters, but in our case, we take a slightly bigger height of 1.0 meters to cater the emergency times, such as lack of water source due to unavoidable circumstances. Then we go to the pipe design. In our case, we have chosen high density polyethylene HDPE as our pipe materials. It have a roughness 120 and the pipe diameter is from 100 to 250. So the reason choosing HDPE as our pipe material is because it is harder, more abrasions and heat resistance. After that, it also able to dampen and absorb shock wave. Then the corrosions and chemical resistance for the HDPE is also high. Next, the value of head loss for each pipe can be calculated using the Hazen-Williams friction loss equations. The rules and regulations is we cannot exceed 2 meters per km for gravity flow. Then the velocity of water flowing in the pipe also need to be calculated out using these equations. This is the data we obtained from e-panels. We can see that the unit head loss of each node is smaller than 2 meters per km, so they have all meet the standards. However, not all the velocities meet the standards because some of them has the velocity less than 0.3 meters per second. This is because the number of loops is too many and also the nodes also too many. Then the difference of elevations in between nodes is too close, so it is hard to achieve velocity greater than 0.3 meters per second. From this table, we can see that the residual pressure is all greater than 7.5 meters, so means that they have met the standard. This is the layout of pipeline with pressure. We can see that the static pressures of all pipeline is not exceeding 30 meters at all flow conditions, so the pressure have met the standard. The first problem that we meet is the water velocity in the pipe didn't meet the requirements, which is in between the range of 0.3 until 2.0 meters per second. In order to solve this problem, the numbers of nodes and loops need to be decreased. In addition, the diameter of the pipe should also be reduced to increase the velocity. Then the second problem is our member find that they keep over pressures when designing the pipe using Ethernet. So our member has studied through YouTube and they find out that they use the wrong pipe. So that's all from me. Thank you. Greetings, my name is Solians. Today I'm going to present the course SEAA3022 Integrated Design Project 1, topic Erosions and Sediments Control Plans. Soil erosion is known as the separations, entrancements, and displacements of soil particles away from their original locations by erosive force such as water, winds, and gravities. So, as the vegetation is removed and soil structure is broken down by compaction during the construction works, the soil particles are entrained and transported as sediments. Sedimentation is the accumulation of materials in a watercourse bed, which will then cause floods due to the rising of bed levels. Therefore, drainage management is a requirement for erosion management on project site. The project site is located in Urutiram, Johor. The total area is 44.39 hectares. So we decided to divide the area into 3 zones, where each of them will be divided again into 4 sub-areas. One of the methods of erosion control is seeding and planting. Seeding of grass and planting of tree can provide long-term stabilization of soil. In general, vegetation is the most suitable and most cost-effective covers for the bare soils. However, it contains limitations. For example, it requires proper irrigation every day. Then, prunings or movings may also require from time to time. Then, it is slow to stabilize the soil. After that, excessive use of fertilizer for the plants to grow will also cause stormwater pollution. Lastly, eroded area would require revegetation or reinforcements with other BMPS. Then we go to the runoff management BMPS. First, we need to know the rainfall estimations. We have assumed a 2-year average recurrence interval, which is known as ARI. Then we also need to find the time of concentrations, which is the time travel of runoff flow from the upstream to the downstream. It is the sum of the overland flow times and the time travel in small stream. To obtain TO and TD, we need to know the Horton roughness and the Manning roughness. In our case, the Horton roughness is 0.0275, while the Manning roughness is 0.025. Next, we need to obtain the average rainfall intensity using this formula. The rational method is used to find the peak flow discharge estimations. In our case, the runoff coefficient is 0.5. After the collections of data from the previous calculations, we can start to construct a temporary earth drains. So in our case, we use a trapezoidal shapes. Then A, P, R, and Q can be calculated using the formula listed at here. The design discharge Q of the temporary drainage must be greater than the peak discharge QP that we obtain from the rational methods, so that it can cater the maximum flow during rainstorm. Here is the overall result for the temporary channel. We can find that the design discharge is always greater than the peak discharge. This is the dimensions of the drainage that we designed. Next, we proceed to the sediments control BMPS. We need to find the soil loss estimations using these equations. The rainfall erosivity factors R is in between 14,000 to 15,000. In our case, we assume our R values as 14,000 at 100. Then we can get our soil erodibility factors K using this formula. The slope length and stiffness factors LS can be determined directly from MASMA table. Next, we need to get the cover management and predict support factors. The C factors is the various types of covering used to protect the bare grounds from rain spreads and shift erosions. P factors it requires to prevent silts and sediments from flowing off the sides in flowing water. We can obtain the sediment yield estimations by using this formula. This is the summary result from the soil loss estimations and the sediment yield estimations. After we have calculated out the sediment yield estimations, then we can start to design the sediment basins. Here are the reference and the design criteria for a sediment basin. Here are the summary dimensions for the sediment basins, and we also sketch out the plan view and side view for the sediment basins. Silt fence is one of the methods of the sediments control. It acts as a linear barrier to produce upstream ponds where the soil particles coarser than 0.02 mm can be collected. The velocity of shift flow will be reduced and so for low to moderate concentrated flow. It is simple to construct, inexpensive, and can be moved easily as the developments progress. However, it only effective for the shift or overland flow and not suitable for the concentrated flow. Check dam is a small dam constructed across a drainage channel to slow the flow. It prevents screwing and channel erosions and are primarily used in a small channels in steep terrains where the velocity exceeds 0.6 meter per second. However, it cannot be used as a standalone replacement because it has low trapping efficiency. Then it also cannot be constructed on a flowing river or natural stream. When doing ESCP, our members are confused on data that need to be extracted from the MASMA when designing the temporary drainage and sediment basins. So, to solve these problems, our members have studied thoroughly the MASMA, especially Chapter 2 and Chapter 12. Then, the second problem is the K value cannot be determined through doing soil tests, so the soil test data and K value was provided by the lecturer. That's all from me, thank you. Greetings, my name is Solians. Today I'm going to present the course SEAA3022 Integrated Design Project 1, topics Cost and Estimations. Cost estimation is the process of estimating all the costs associated with completing a project within scopes and according to its timelines, which include the site clearance, topsoil excavations, cut work which involve soil excavations and transportations, field works which involve soil spreading and laying, and lastly is the soil compactions. A realistic, accurate, and precise cost estimate can help overcome a problem overrun. These are the machinery used during the constructions. The first one is excavator, which used to dig out or transport huge items, and the second one is dump truck used to move or transport bulk materials. The third one is chainsaw used for site clearance in which to cut down the trees, and the fourth is the loader used to move or load materials. The fifth one is bulldozer used to drift, dig, excavate, and level items such as dirt and rumbles, and the last one is soil compactor, which used to compress soil after it has been filled to prevent bucklings and to improve the soil stability. Here are the earthwork specifications that need to take in account when the cost estimations. The first one is site clearings, including the tree cuttings, tree roots and stump removal, and tree disposal. The second one is excavations of topsoil and transportations. The third one is cut work, which including the excavations of cut work, loadings and transportations from cut to field. And the fourth is field work, which including the import materials to field and the compactions. Here is the considerations of cost estimation. First one is the labor. We need to know the level of skills of the labor, whether he or she is local or foreigner, and the hiring periods. The second one is material, which we need to take in account the transport fee and the discharge fee. The third one is the plant or machinery, which including the fields, operator, hiring rate and outputs. And the last one is the profits, which is 20% of profit need to be taken account when the cost estimations. Here we continue to the value engineering, which used to reduce cost and increase functionality to increase the project value. In our project, we aim to achieve 30% cost reductions, and we have selected 3 value engineering initiatives. The first one is reductions of total volumes of cut and fill. This will decrease the total volume of soil that require excavations, transportations, and compactions of works. The desired level will be based on the previous proposed level, and the higher level areas still maintain higher, so that the drainage flow and pipeline is not affected. The second initiative is certain areas are preserved, and this area is act as buffer zones. Tree in this area is not need to be cut, so that it can reduce the cost for soil excavations and tree cuttings, and at the same time protect the environments. The third initiative is replace some of the skilled workers with semi-skilled workers. So skilled workers more focus in making decisions, while semi-skilled workers more focus on physical works like equipments and machines handling. So semi-skilled workers can be hired to operate the machines and equipments on site with a lower cost than the skilled workers. This is the result of bill of quantity. Here is the first attempt, here is the second attempt, and we can see that the cost estimations have a big reduce at the second attempts. After calculations, we get a 38.71% of cost reductions, and it is higher than the requirements 30%. So we say that our objective is achieved. The problems that we meet in the cost estimation is the cost estimations before the reductions were too high, then the heavy use of machines or equipment have made the cost high also. So the member discussed with the above departments members to reduce the cut and fill volumes in order to achieve 30% cost reductions. Then they also increased the buffer zones, not only to protect the environments but also to reduce the area need to be cleaned before the construction works, save the labors and machinery costs. So that's all from me. Thank you.